Okay, yes, so to review, the sum of all multiples. So first of all, we have multiples of n. We want to hone in on that. And then I look down at the examples. N is my first argument, so 2. Multiples of 2 would be 2, 4, 6, 8, 10, 12, etc. And I see here, indeed, I have 2, 4, 6, 8. Now, it stops at 8, so it doesn't include 10, which would be the next multiple of 2. Why is that? It's because the next argument is m. M in this case is 9. So once we hit 9, we stop. And next, we go back to this part of the problem, find the sum of all multiples. So I've got this set, 2, 4, 6, and 8. Now I need to add them all together, which will give me my result. Let's go to the next example and look at it. So n is 3. So I'm going to want multiples of 3. I know those would be 3, 6, 9, 12, 15, 18, etc. And then I've got m of 13. So I start at 3. I get 3, then 6, 9, 12. Now I knew the next one was 15. However, in this case, we've hit 13. And so we'll stop. And now we'll go ahead and add them all together and we get 30. So let's talk about some examples and cases before we solve the problem. So we have, let's make a list here. We'll call this cases. Now, cases are going to describe the relationship of n and m to each other in this problem. So it's not even about code. We're just going to talk about what could be possible between n and m. So first of all, we could have n is less than m, and m is not a factor of n. So we've seen two cases like this. For example, 2 and 9 would fit this example. 2n is less than m, 9, yep. And m is not a factor of n. Yeah, well, 9 is not a factor of 2. So that would be true in this case. And then we looked at another case like that, 13 and 3. n, 3 is less than m, 13, yep. And m is not a factor of n. Well, 3 times 4 is 12, and 3 times 5 is 15, so that's right. Yep, 13 is not a factor. Okay, we get two examples of that case. Let's move on to the next case. N is less than m, and m is a factor of n. Okay, what could this be? We could do 2 and 8, for example. 2n is less than m8, and m is a factor of n. Yep, 2 times 4 equals 8. So if we count by 2s, in other words, we get 2, 4, 6, 8. So great, that would be an example there. And then let's do an example 4 and 12. 4 is less than m, yep. And m is a factor of n, sure. If we do 4 times 12, or 4 times 3, we would get 12. Now, notice we haven't really solved for any of these cases yet. That's okay. We just want to sketch out different possibilities we might have to handle in our problem. N is less than m. Okay, how about n is 4 and m is 3? Well, in this case, the first factor of 4, or the first multiple of 4 is 4 itself. And that already is larger than 3. So we would have to see what is our expected result in this case. Of course, we could give one more example. We could do 10 and 5. So 10, the first one would be 10, but it's already out of range. N is equal to m. Okay, easy enough, right? We could start with 2 and 2, or 5 and 5. So the first multiple of 2 is 2, but m is 2. And the problem says, referring back to the problem, m is excluded from the multiples. So even though we could get 1, 2 out of this, because m is excluded, essentially we have nothing to add together. And same would be true here. Okay. Now, we could think about negative numbers, but I think it says N and M are natural positive integers. Now this is a bit belied by the fact that one of the examples gives M as a negative number. And then we see when that happens, we see invalid. So this bears a bit more investigation as far as how that should be handled. But I'm going to go off of this, that we are working with only positive integers for now. And so I'm not going to look at any negative cases. Now, is there anything else that I'm not thinking of that could describe a relationship between N and M that we haven't looked at in these four relationships here? I don't think so. But this, what we did right here, that is pretty much the hardest part of solving an algorithm. And it's also the hardest part of being a software engineer. This might seem like this is a pretty easy problem, but really thinking through all the cases of what can happen is itself one of the most core skills of being an engineer. Because now we just have to make sure we write code to cover all of these cases, but at least we've identified all the cases. We can always turn around to a coworker and say, hey, how do I write the code for this particular case? And figure that out, or we can figure it out with some practice or some Googling or whatever. But no one in the world is going to, when we come up with a new problem, is going to tell us all the cases. It's up to you. Of course, you could collaborate with someone or get some help, but it's really up to you to develop this skill to think, what are all the different things that might happen given the inputs that I'm getting here? And I'm going to go on a quick tangent here to give an example of a practical example. On the Codewars tracker, the first thing you see, well, not first, but this component here, right? This week's top scores with the first, second, and third place by their points this week. So we see 48, 42, 33. So let's then just think about this as cases. We'll call this a podium with 3 winners. First, second, third. Now, of course, the easiest case is 3 or more scores where the top 3 are greater than 0 and not equal to each other. So if I had, let's make a little array of scores here. Let's say I have 45, 23, 56, and 10, right? Of course, I could have more here. Well, it's very easy then for us to figure out who's first place. 56 is first, 45 is second, 23 is third. But of course, we cannot assume that our data would look like this. So we have to think about some other relationships as well and how we would want to handle that. How about less than 3 scores above 0? So at the beginning of the week, when the scores are reset on this app, the array looks like this, 0, 0, 0, 0. Until somebody does score some points for that week, we just have a bunch of zeros. Well, what do I do in this case? If it was my job to write this component at work, and I didn't think about this, and no one else had thought about it before me, this would be a problem on your job, because all of a sudden Monday comes and your boss saying, hey, how come the top 3 scores are 0, 0, 0? That doesn't make sense. What's going on here? So we think, okay, well, what do we do if we have, I'm sorry, I did this wrong. Less than 3 scores above 0. Let's say less than, no, change this, no scores above 0. So that would be a case. Then we have a case, 2 of the top 3 scores are tied. Well, of course, we could look at data that was like similar to this data here, except for instead of this 10, we have another 46. Oh, well, now I have 56, 46, 46. Our scoreboard is a fairly trivial example because no one is going to get in trouble or die or lose money if we don't quite rank them in the right order. But many times things are a lot less trivial in life than that. So it would behoove us to think through, well, what do we do if we have if second and third place are tied? Of course, we could have all three top scores are the same. Then we could have less than 3 scores above 0, where we have something like, 0, 10, 45, 0, 0. So easy enough to see that first place is 45, second place is 10, but now I've just got a bunch of zeros. What do I do about that? So I hope this starts to sort of illustrate how a lot of the work is actually in understanding the problem and then understanding all the different cases that we might look at in that problem. Even for an example, it's pretty simple that we're working on Codewars. We have at least 4 cases that we need to consider and take care of. And with something as simple as a scoreboard, we haven't even exhausted all of the different cases here. There's going to be a few more cases that we need to think about and then decide very explicitly how we should handle them. So when you go into an interview and you first seek to understand the problem, then maybe ask any clarifying questions if necessary. Then what I would do next is I would start to sketch out some cases, and maybe you don't write it out all like this. It depends a little bit on the interview. If I was typing though, I would probably do something exactly like this. I would say, okay, well, first something, it's the obvious one would be like we've seen, n is less than m, and m is not a factor of n. So it doesn't even matter if n is included in the set or not, because it would always be excluded anyways, because it's not a factor. Then we have a similar case, though a little bit more tricky, where m is a factor of m, so it would normally be included, but the problem has explicitly said that m is not included. So we need to make sure we handle that. Then we could have n is less than m. In that case, I might ask some clarification. What do I do in that case? Would I return 0? Would I return some kind of error or something else? You could ask the interviewer, of course, you could interrogate the platform, look at the problem and understand better. And then if I have n is equal to m, again, I have a little bit of a question. Is this supposed to return 0? Should it return something like -1 or something else? I'm going to assume that it returns 0 since the sum of the factors is 0. Are there any questions about that, how we kind of explore the different cases that are possible through a problem? Again, anyone feel free to just speak up if you just want to yell.
I have a question.
Yeah, so go ahead.
Is it that you're able to come up with all these cases because of like doing this over and over? Like, I feel like you come up with these cases really quickly.
Yeah.
What to look for. And so I was wondering, is there like a way or specific things to look for when coming up with these cases, or is it just like multiple practice that you've come up with this?
That's a great question. It's mostly practice. Yeah, I'm going to tell you it's mostly practice. It's mostly practice. Yep. And I would say that I don't have some people are much better at methodical thinking than others. I am not someone who is very naturally gifted at that. So I have to practice even more than a lot of people that I have worked with because it doesn't come naturally to me. If you tend to be a more creative or intuitive thinker, then it is really a skill to develop this kind of thinking. And it just takes practice. And, but it also, you kind of have to use some imagination in this. Well, what relationships can I imagine between n and m? And then as you code more, you solve a problem, you think, you submit the solution, and you realize, oh, I totally forgot, such and such case. I totally forgot n is less than m. I didn't handle that, and therefore I didn't get a solution. But it is important to practice this and should be looked at as a core part of solving any problem. Now we're doing this in a pretty longhand way here, which is fine. I don't know that it's always necessary to do this, but when you're testing, it is absolutely necessary to do this. And we're going to look at that now. So now here on Codewars, I'm going to go ahead and start the problem, and please all follow along with this. Now here, Codewars is awesome because it gives us the ability to write tests. So we're going to use the cases that we developed, and we're going to start writing tests for each of those cases. So I'm going to go back and refer to my cases. And I'm going to start with what seems to me the easiest case. N is equal to M. So I'm going to take that. Now, if you're not familiar with testing, we're going to use an it block to test each case. And inside of it, we're going to put what goes inside is going to be equivalent to the examples we've given here, where we try exact examples that meet that description. Excuse me. So Codewars oftentimes just has something kind of stubbed in. So I'm going to test sum mul, meaning these are going to be tests for this function here. N is equal to M. So here I have test assert equals, meaning I'm going to call the function with some values, and I'm going to put what I expect to get back. So I'm going to start with 2 and 2, like we did. You'll realize I'm getting that example from right here. And when we have 2 and 2, we expect to get 0. Okay. Now I'm going to go up here and ask myself, okay, what code would I need to write in order to pass this test? Well, I need to return 0. And I go ahead and test that. Great. So this case is passing. Now I will add another example. Now, again, because we've already told ourselves what we're testing here, so I'm going to make sure that my arguments match that. So we did 5 and 5, and we expect 0. And I'm going to run it again. Cool. If this, and I wouldn't blame you if you thought this, if you think, well, this is very tedious for such a simple problem. Yeah, you're right. I'm not denying that. For anyone who was in class last week, hopefully that gives a glimpse of how fast problems get much more challenging than this. So it behooves us to develop the rigor in how we approach problems now, so that when we get to more and more complicated problems, we have already developed quite a lot of practice with very engineering thinking, very much thinking through, well, what exactly can happen in this problem, and what are all the different ways that can happen, and how do we handle all of those ways. All right, I'm pretty convinced we've got a good thing going here. So I'm going to move on to my next test case. And I'm just going to refer back to my notes here. So I've got N is equal to M. We could check, oops, let's say we could check that off. Okay, N is less than M. Sure, let's do that now. So I have N is, I think that's a typo, right? What I want is N is greater than. Sorry about that. So I have N is greater than M. And then we follow that up with our test. Test assert equals sum mul. Now, again, I'm just going to go back to my notes. N is greater than M. Great. I got 4 and 3. Let me just take those here, put them here. And in the case that N is greater than M, I believe, based on nothing more than this here, that our expected answer is a string called invalid. So if I run my tests, well, I'm passing those first two and failing this last one because I haven't made any changes to my code. So let's go ahead and do if N is greater than M, return invalid. Therefore, it needs to be capitalized. And I'll go ahead and test that. Okay, all my tests are passing again. I'm going to copy this line. And I'm going to do another example. And I'll just go back to my notes. I've got 10 and 5. So go ahead and paste that here. And I'm going to test that. Great, still working, all good. And now we could always do more tests in each of these cases, but I'm pretty sure 2 tests gives us enough assuredness in what we're doing. I'm gonna go to my next one. Now I'm gonna
So
do this. Go ahead.
Angelina asked the question of why we're doing the test. If there's
Why are we
tests-
doing the tests?
Yeah, why are we making tests if there's tests already there?
Because when you go into an interview, and especially when you go into a job, no one will write tests for you. So we want to develop that skill now, because part of your job as an engineer is to write tests. And if nothing else, writing tests will give us it enforces that kind of discipline to think through, well, what all do I need to test here? What are all the cases that could come up in this problem? And how do I handle all of those? And am I sure I'm handling those correctly? Were you in class last week?
Who, me? No, I wasn't in class last week.
So you might want to go back and watch the video from last week. We were working on a different platform called Codility. And on Codility, which is set up more for proper interviewing, when you submit your problem, that's it, you're done. Whatever you tested until then, that's where you're going to be. And so if you forgot to test certain cases, you can't go back and resubmit the problem. You can't go back and change your answer. You have to develop the ability to think through all of the things you might want to test first, and then away you go. Just like in a job, you're going to be assigned some kind of problem. For example, hey, make a scoreboard and make the top 3 and you don't want to get a call on Monday morning, for example, hey, how come the top 3 scores are all 0? Oh, well, yeah, that's your job to think about that and figure that all out. And of course, again, that's such a trivial example. A better example is get called at 11:30 at night. How come our order processing isn't working? We're losing, hundreds of thousands, if not millions of dollars, as we see these orders come in and not work and go to our competitors. Oh yeah, I didn't actually think about such and such case, and now that's causing some kind of problem. So that's why we write tests, because in the real world, we'll have to write tests, but also even on most coding platforms, especially if it's an interview, you will get a one and done type approach. You will get to do your problem, submit it, and that's that. You won't get to see the test you failed and then change your answer to pass those. Does that make it a little more clear?
Yeah, thank you. I mean, yeah.
Okay. Someone else had their hand raised, I think. No?
Yeah, I was gonna ask something about the test as well. So, Codewars has like the first part that says describe, right? It has test, and then it has the like capital test, and then when it's using the it has it in lowercase test.
Mhm.
I'm not sure how those two are related. Does it matter? Is it checking for like the strings to be capitalized or not? I'm assuming these tests are already incorporated into like Codewars.
Yeah, so the Codewars test looks a lot like Jest, and Jest is incorporated into React, and probably most of you are doing your capstone project in React. So without like diverting too much, yes, you have a describe block that tests usually one function or sometimes one component if you're working with more like a front end type thing like React. And then it is describing, this is just human readable language here. You'll notice I made my notes over here on Replit, and then I'm just copying them over to here. The computer doesn't care what we put here. This is just for me and anyone who might come after me that wants to see these. And then test comes from the actual library that has a method called assert equals. Assert equals takes 2 arguments. The first one is the actual function we want to test with the specific arguments we want to test. And the second is what we expect the return value to be given these arguments. Is that cleared up a little bit?
Clear, yeah, thank you.
Okay. When you guys move on to being in employment full-time, we do more classes on testing and how it works, and we'll certainly learn a lot more about this as we go. For now, you can just kind of focus on we call the function, and we specify exactly what we expect to get back from the function. Okay, so let's go to our next case, right? I think I already have it here copied. So I'm going to type out it. And we could just modify this a little bit. Solves for n is less than m, and m is not a factor of n. Then we want to do comma, callback function. And in here, I'm typing these out, but if you just want to copy, copy the previous block and paste it and then type into it, that's fine too. Just write over it. All right, so I'm going to do assert equals sum mul. Again, I'm just going back to my notes and my numbers 2 and 9. Put those here. Now, when we get 2 and 9, we know from the instructions here, right, that we expect 20. And we know because we get these and we add them all together and we get 20. So I've got that. I'm going to run my test. What do you know? It failed. No surprise there. So now we can say, all right, we need a solution for some actual numbers now. So let me go ahead and figure out how we might solve this problem. Let's say we're going to make a loop. In every iteration, get a factor of, not a factor, but a multiple of n. Add it to a total. And then down here, I could change this to return total. And finally, up at the top, of course, if we're going to have that, we need make a total. All of this just comes with practice, right? So if any of that just seemed kind of fast to you or whatever, I think by the time we finish the problem, it will be clear. But the only way I got fast is by practicing. So that's that. Hey, Jonathan, I see a comment that said, yes, it does actually. What is that in reference to? That's something I should respond to.
That had to do with something you answered a while ago.
Oh, okay. Okay, so I'll set my total up to be 0. Interestingly, we can notice, oh, actually 0 and 0. If I don't do anything else here and I just return total here, it should be that I'm still handling these cases up here. I could even run it to test that, to make sure that I haven't backslid and failed to test any of my, or failed to pass any of my previously passing tests. So I can see here, yep, I've got my first block of it statements passing. I've got my second one passing still, cool. And on my third one, I'm still failing, no problem. Make a loop for let I equals n in this case. I is less than or equal to m. I plus equals n. So instead of, you might have often started I at 0 or 1, something like that. In our case, when we look at the examples here, if we think of getting these values from a loop, we don't want to start at 1 because we don't actually need 1. What we need to start at is wherever n is. And then every time we go through the loop, we're just going to add n to it again. So the first one, n is 2. The next time we go, n plus n is 4. 4 plus n is 6. 6 plus n is 8, etc. So then I can do total plus equals I. In every iteration, get a multiple of n. Yep, we should be getting that right here. And add it to the total. We should be getting that here. I'm going to move these in here for now. So thinking through my numbers here, 2 and 9, let I equals 2. 2 is less than 9. This won't happen until the end. total plus equals 2. Good, that will be 2. Then I should become 4, and then that would get added, and etc. up to 8. Eventually, I would become 10. 10 is not less than or equal to m. Therefore, and in fact, because m is excluded, I need to make that just less than. So with that code in place, I'm going to go ahead and run my test. I hypothesize that I've written code that would pass this here. Great. So we see that we continue to pass all of our previous tests, and we are now passing our most recent test. Well, that takes me to my next set of numbers, 3 and 13. And I will just write another test here. And 13. And we could do this pretty easily longhand, but since we've already got the answer here, we're going to go with that. We've got the answer 30. And I'm going to test that again. Good. Now it's still passing that case. Perfect. Now we've got one more case we need to consider. And that was n is less than m, and m is a factor of n. So let me copy that. And we'll write our last set of tests here. Copy this. Cool. Now I want to change these values here. Again, I go back to my notes. I've got 2 and 8. So just need to change that. Now, 2 and 8 would mean 2 plus 4 plus 6 plus 8, except for 8 is matching m, so it is not included. Adding these together, we would get 12. So I'll go ahead and put 12 here. Delete my comment. And I'm going to go ahead and test that. Great. We see that it's still passing that case. So it looks like we don't need to make any further alteration to our code. Though that's not always the case. Sometimes when we solve for one case, we will have solved for another case, though not always. And well, let's do one more of this, 4 and 12. So I will, let me just copy this. And I've got 4 and 12. So to longhand that, I would say, well, it's 4 plus 8. Next one would be 12, but 12 is equal to 12. So I just have 4 plus 8 is 12, which equals 12. So incidentally, it's the same value. That's interesting. And I'm going to go ahead and test that. Great. Okay. Now I need to check for, yes, go ahead.
You can call me Obi.
Obi. Okay, thank you. Obi, go ahead.
Thanks, Jordan. Sorry to interrupt. I have a quick question about the loop. Why do you have it as I plus equals n as part of the loop instead of I plus plus?
Got it. So great question. Thank you so much for asking. Please, anyone interrupt, like Obi, anytime, just ask. I would much rather you ask and get, I'm not mad about it being interrupted. Just ask. It's great. Okay, let's talk about it for a second. Generally, if we have I plus plus, right? If we started with I equals n, let's look at a particular problem. Let's think of this one, 2 and 9. So I equals n, where n is 2. So on the first iteration, I is going to be equal to 2. And then if we called I plus plus, what is I going to be equal to after that on the next loop?
3.
Do you know? 3? 3. And if we followed that, what would I be on the next iteration? What would I be equal to?
4.
4. Perfect. 4. Yes. Now, in a lot of cases, especially if you're maybe iterating through an array and you want to look at each index, then something like this pattern would be perfect because we want to look at the 0th index and then the first and then the second and the third and so on and so forth until we get to the last one. But in our case, we don't want a pattern like this. We want a pattern that looks more like this pattern here, where we're counting up, yes, but we're counting up by the value of n. So if we were to start at 3 and then add 1 each time, we could, for example, even do that and then check and say, well, I want to add 1 each time, but if it's not divisible by 3, I don't want to add it to my total. that will just give us a bunch of intermediate steps where we say, okay, 3, add that to the total, 4, no skip, 5, no skip, 6, oh yeah, okay, add that to the total. But we'll be doing a lot more work than we need to. Since we explicitly know we only want the multiples of n, we just say, hey, start I at the first multiple of n, which is n itself, and then go ahead and increment I by n, because adding n each time is going to give us the next multiple. Does that make sense?
Yeah, absolutely. Yep, that makes it a lot clearer. Thank you.
Okay, no problem. Thanks so much for that question. I'm gonna delete that now. Yeah, so with this, then we end up with, if our example is 2, then the first time is 2, then we add n to it. N is 2, so we end up with 4, then we add n and 6, etc., until we hit this condition and we stop. Okay. Now, there's one other thing I want to look at, and that we didn't consider too much before. I'm going to add one more block, and I'm going to put in here. I'm going to put in here n, oops, or m are invalid. So what would make numbers invalid? Well, if they were less than 1, that would be one case. So let's try that. We'll do 0 and 0. And the expected response here is a string that says invalid. Let's just make another case real quick. If we had -1 for m, and let's just leave it at 12, this also would be invalid. And then we'll do one last case. We'll do the opposite. Test assert equals sum mul. We'll do 3, and we'll do -12. And again, the expectation is here invalid. Okay, so again, I'm just going to run that, see what we get. Anyone have an idea what's happening? So it failed. Good to know. We got a timeout, and we got a timeout because when our loop gets these values, it fails to work properly. Infinite loop. Thank you, Du-Min Chen. Hope I'm saying that right. Yes, it's an infinite loop. So again, this is just like easy stuff to miss that you just got to make the practice to think through it. Okay, so we want to find the logic to fit it all into this case here. We don't want to write return invalid anywhere else. So let's just think about how we might do this. If n is greater than m, or n is less than 1, or m is less than 1. Let's try that. Cool. That solves it. There might be a way to condense this a bit further, but we won't worry ourselves about that too much right now. So I feel pretty good that we've got all the cases covered. Now, back to the wonderful question of why would we write tests like this? First of all, the tests given to you on Codewars are not nearly comprehensive enough. But even more than that, I encourage you to just delete the tests anyways and learn to write your own tests. It will be one of the most valuable skills you can develop as a software engineer. And finally, on Codewars, I'm very aware, and this is as it should be, that when you click attempt, you can just click attempt as many times as you want. You won't get penalized, you still get points. It's all good. But our goal should be that when we click on attempt, we get green every time. And that means that's equivalent to going to an interview and getting 100% on the interview, or getting some kind of 100% passing ability. It means I really thought through all the cases, and I didn't use the built-in test as a crutch, because in real life, there will be no built-in tests. I will have to just do it myself. So I'm going to go ahead and click on attempt. Oh, all right. This is a small problem, but I should have paid attention more. Invalid needs to be all capitalized. So, oops, not just the I, but the whole thing. And then I will have to change that here as well, if I want these to work. And now I'm gonna run my local tests again, make sure that it's all in working order, and then I will go ahead and attempt that. There we go. So I did make that mistake. I should have looked more closely at the example here to see that it's all capitalized. Okay. That's great. That is